Honors Chemistry Section 7.2 lesson video, and so again we are talking about ionic compounds. So we kind of started talking about ions in Section 1, and so now we're going to start putting the ions together. And so that's through a process called balancing charges, and so that's a very important process for you to be able to learn to get through the rest of the year. So compounds composed of cations and anions are called ionic compounds. Ionic compounds are usually composed of a metal, because metals tend to have positive charges and be cations, and a nonmetal, because nonmetals tend to be negative and form anions. In contrast, molecular compounds, which we'll learn more about in Chapter 8, are generally only composed of nonmetals. And so the important thing to remember is metals are on the left of the periodic table, in the middle, and under the stair-step line for metalloids, and at the very bottom, there's lanthanides, actinides. Your nonmetals are to the right of the stair-step and hydrogen. Although ionic compounds are composed of ions, the overall compound is neutral, so that's where the process of balancing charges comes into play. So even though it might be made of an ion that's +2 or -3 or something like that, once they bond, they have to cancel their charges and become neutral, otherwise it's not stable. The electrostatic forces that hold ions together are called the ionic bonds. So remember, I told you that ionic compounds tend to be made of metals and nonmetals, and molecular compounds tend to be made of only nonmetals. So it says, which of the following compounds would you expect to be ionic? Well, N and O are both to the right of the stair step. So by the right of the stair step, what I mean is, if you think back to Chapter 6, where we talked about that stair step line that separated, or that kind of identified our metalloids. Everything on this side, all the way to up under the stair step, are metals. Everything on this side of the stair step line are nonmetals and hydrogen. So hydrogen is a nonmetal. That's why sometimes you'll see it put next to helium. So everything to the left of the stair step except hydrogen are your metals. All right, so if I look, N and O are both nonmetals, so that would not be ionic. Na is a metal, O is a nonmetal, so this one would be ionic. Ca is a metal, Cl is a nonmetal, so this one would be ionic. S and F are both nonmetals. So those two would be my ionic compounds, and the other two would be molecular. So now that you saw how I did it, why don't you try the next one? So there's my answers. So the next one says, which of the following are molecular? So remember, you're looking for only nonmetals. I'll assume you've paused it and tried it, and let's look at it together. So C and Br, those are both nonmetals, so that would be molecular. For Fe and S, Fe is in the middle, it's a metal, and S is a nonmetal, so it would be ionic. P and O are both nonmetals, so that would be molecular. Pb is under the stair step, which still makes it a metal, and F is a nonmetal, so that would be ionic also. All right, so for this one, again, there was two answers. It was CBr4 and P4O6. So the important thing to know is where your metals and nonmetals are, so that you can tell if something's more likely to be ionic or molecular. So a chemical formula shows the kinds and numbers of atoms in the smallest representative unit of a substance. A formula unit is the lowest whole number ratio of ions for an ionic compound. So like salt or sodium chloride is NaCl. That doesn't mean if I hold a grain of salt, I'm literally holding one sodium ion and one chloride ion. It just means the ratio is 1:1. So it's the lowest whole number ratio, not necessarily the exact amount that you have in a sample. So, balancing charges. This is super important. When you balance charges, to write the formula for an ionic compound, you must make sure the positive charge and the negative charge equal by adding subscripts. The subscripts must be in the lowest ratio to be correct. So sometimes we call balancing charges crossing charges, because if you look, if you have a +2 and a -3, you can take just the number. Notice they're not bringing down the negative or positive, just the number down. And so I can bring the 3 over here, I can cross the 2 here, and then that makes +6, -6. And so +6 and -6 cancel out. Now it has to be in the lowest ratio possible. So let's say you have this right here, and you cross your 4 and you cross your 2, so you have 2 and 4. That's not the lowest ratio possible, so I need to reduce it to a 1 and a 2. Okay, so that's what crossing charges is. So let's look at quite a few examples because this is super important. So remember, to find charges, you just utilize your periodic table. So I'm just going to put it up here once for this lesson video, and then I'm going to assume you have one that you can look at. Okay, so the first group is positive 1, positive 2, the whole middle is positive something. Group 13 is positive 3, 14 is positive or negative 4, 15 is negative 3, 16 is negative 2, 17 is negative 1, and group 18 has a 0 charge because they're already stable. All right, so it says write the formula for the compound formed between the following elements. So potassium is K. Potassium is in group 1, so it has a positive 1 charge. Remember, the 1 is understood, so I won't write it. Oxygen is O. Oxygen is in group 16, so it has a negative 2 charge. So a positive 1 and a negative 2 do not cancel. So you take the number, not the charge. So notice there's no actual number written here, so I'm not going to cross anything. Here I have a 2. I'm not going to bring down the negative, I'm just going to cross the 2 down. Because see, then I have positive 2, negative 2, and that cancels. So my formula would be K2O. Now, you don't need to write the charges, so if your answer looks like this, that's fine. I just keep the charges in class so you can see where I'm getting it from. But when I'm checking these, I'm checking your subscripts, not the charges themselves. All right, so next is magnesium and nitrogen. Well, magnesium is Mg. It's in group 2, so it has a positive 2 charge. Nitrogen is N. It's in group 15, so it has a negative 3 charge. So positive 2, negative 3 don't cancel. So again, I cross the numbers only, not the positive or negative sign. So I'm going to cross my 3 to here. I'm going to cross my 2 to here. And see, then it's positive 6, negative 6. And so again, your final answer, you don't need to have the charges, but if you do, it's okay. I'm not going to count it wrong. But really what I'm looking for is Mg3 N2 is what I'm looking for. All right, the other important thing about crossing charges is the positive one is always listed first, so don't ever list your negative one first. All right, so let's look at a couple more. So see, this is the answer that I'll be looking for. Like I said, if you leave your charges though, that's fine. All right, so maybe pause it and try these. Remember, if it already cancels, do not cross charges. We only cross charges if they don't cancel. So I'll assume that you have tried this already. Just to let you know, I put all my positive ones first, but if I did not, you would need to make sure to switch it and do the positive one first. So I'll assume you paused it, so let's look at it. So potassium is K. It's in group 1, so it has a positive charge. Iodine is I. It's in group 17, so it has a negative charge. Since positive 1 and negative 1 cancel, I don't do anything. So my answer is just Ki. So hopefully you got that right. Next we have aluminum, which is Al. It's in group 13, so it has a positive 3 charge. Oxygen is O. It's in group 16, so it has a negative 2 charge. So positive 3 and negative 2 don't cancel, so I do need to cross. So I take the number only, 2 and cross down here, and 3 and cross down to the O. So see, now it's positive 6, negative 6. Remember, you don't need the charges on your answer, but if you leave them there, it's okay. All right, so hopefully you got that one right. So next one is calcium and chlorine. So calcium is Ca. It's in group 2, which has a positive 2 charge. Chlorine is Cl. It's in group 17 and has a negative 1 charge. So positive 2 and negative 1 don't cancel, so I bring the number only down. Since the negative doesn't have a number, I don't need to bring anything down. The whole thing, y'all, is there's technically an understood 1 here, but there's technically an understood 1 there too. So we just don't need to do anything with the understood ones. Like, please don't write them. Like, yeah, I'm probably not going to mark it wrong, but if you keep doing it, I will. Like, the one's understood. All right, so CaCl2 for that one. So hopefully you got that right. All right, last one. We have barium and sulfur. So barium is Ba. It's in group 2, so it has a positive 2 charge. Sulfur is S. It's in group 16, so it has a negative 2 charge. So you have to be careful, y'all, because some of y'all, you get so good at crossing charges, you cross when you don't need to. Ba has positive 2, S has negative 2. Those already cancel, so you don't need to cross. The problem is if you cross, a 2 and a 2 can be reduced to 1 and 1. So that's why I say if they already cancel, don't cross anything because you're making it wrong at that point. All right, so that is how crossing charges or balancing charges works. Now we're going to learn how to do it when you have something called a polyatomic ion. So hopefully you got this right. And so again, these are the answers that I'm looking for. If you leave your charges, that's fine, but they're not necessary. All right, so like I said, hopefully you got your charges taken care of because I'm not going to draw this up here again. So polyatomic ions are just a group of atoms with an overall charge. When a compound contains a polyatomic ion, the ions are held together by ionic bonds, but the polyatomic ion itself is made of covalent bonds. So the polyatomic ion is held together by covalent bonds, but when it bonds to another ion, it's held together by ionic bonds. So an ionic compound that contains a polyatomic ion has ionic and covalent bonds. When balancing charges for polyatomic ions, you still follow the same rule of canceling the positive and negative charges. However, if you need to add a subscript to a polyatomic ion, you have to put it in parentheses. So that's the only difference. Okay, we're still just crossing charges. So like Ca has a positive 2 charge, NO3 has a negative 1 charge. Okay, and you'll have a list of polyatomic ions in your packet. So I need to cross the 2 down, but since NO3 is a polyatomic ion, we just put it in parentheses and then put the 2. That's all you have to do. That's the only difference. You can't like take away the 3 and change it to a 2 or anything like that. You have to keep the subscripts that come with the polyatomic ion. Now, not all polyatomic ions have subscripts, like there's hydroxide, which is just OH, cyanide, which is just CN, hypochlorite, which is just ClO. They still need parentheses, whether they have their own subscript or not. All right, so let's look at a couple of these. So we have sodium and phosphate. So sodium is Na, it's in group 1, so it has a positive 1 charge. Phosphate is a polyatomic ion. You can recognize your polyatomic ions because most of them end in ate or ite. And then eventually you'll just get used to them because you have to memorize them anyway. Surprise! So phosphate is PO4 with a negative 3 charge. So remember, I got positive 1, negative 3. That doesn't cancel, so I cross the number only. Don't let the PO4 throw you off. If that's throwing you off, just cover it up. I got positive 1, negative 3, so I cross down the 3. So Na3PO4. All right, our next one, ammonium, is our one positive polyatomic ion that's on our polyatomic ion chart. So ammonium is NH4 positive. So that's on your polyatomic ion chart. Nitride, if it ends in I, unless it's like hydroxide or cyanide, it's just an element off the periodic table. So nitride is just N. N is in group 15, so it has a negative 3 charge. So again, don't let the NH4 throw you off. I have positive 1, negative 3. I need to cross the 3 down, but this is a polyatomic ion. So I just put it in parentheses. So it'd just be parentheses, NH4, close parentheses, 3, N. Just like that. And then a lot of people question, well, does the positive go in or outside the parentheses? Remember, it doesn't matter. The charges don't actually need to be there. All right, but technically, I guess it would go inside. So next one is aluminum carbonate. So aluminum is Al. It's in group 13, so it has a positive 3 charge. Carbonate is on your polyatomic ion sheet. It's CO3, negative 2. And so a positive 3 and negative 2 don't cancel, so I bring down only the 2, not the negative. And then here I need to bring down the 3. Now y'all, you can't just be like, oh, well, there's already a 3 there, it's good. You have to add the 3. So to do that, you'll put it in parentheses and then put your 3. Okay, so doing polyatomic ions is just like doing the other ones, it's just sometimes you need parentheses. Alright, so you pause the video and try these 3 real quick, and then I'll assume you've done that, and let's look at them together. So we have barium nitrate. So barium is Ba, it's in group 2, so it has a positive 2 charge. Nitrate is on your polyatomic ion sheet, is NO3, negative 1. Positive 2 and negative 1 don't cancel. I need to cross the 2 down, so I put it in parentheses and put my 2. So hopefully you got that one right. All right, our next one is lithium phosphate. So lithium is Li, it's in group 1, so it has a positive charge. Phosphate is PO4. It has a negative 3 charge. That's on your polyatomic ion sheet. We have a positive 1 and a negative 3. Since those don't cancel, I need to cross my 3 down. And so then that's it. Hopefully you're getting these right as we go. Last one is strontium sulfite. So strontium is Sr. It's in group 2, so it has a positive 2 charge. Sulfite is on your polyatomic ion sheet. It's SO3 with a negative 2 charge. And this is where you gotta be careful. Some of y'all, you get real fast at it, so you cross when you don't need to. This is positive 2, negative 2. It already cancels, so I don't cross anything. So your answer for that one is just Sr, SO3. Okay, so hopefully you get real good at balancing charges real fast. The better you are, the better the next couple of units is going to go for you. All right, there's my answers. All right, so let's talk about some of the properties of ionic compounds. So some of the properties include that they tend to be crystalline solids. When you think of an ionic compound, just think of salt, because that's an example of an ionic compound. So it's a crystalline solid. They tend to have high melting points. High melting points is normally considered over 300 degrees Celsius. They can conduct electricity when molten or aqueous. So molten just means melted, aqueous means dissolved in water. So solid salt does not conduct electricity. But if you melt salt or make salt water, it will conduct electricity. They tend to be made of metals and nonmetals because, of course, you need a positive and a negative. They tend to be made of cations and anions because, again, you need a positive and a negative. And they are made from ionic bonds. We'll learn about covalent and metallic bonds later. Okay, so these are just some of the properties of ionic compounds. And so this is just what's actually happening, just in case you're having trouble visualizing it. So we start with sodium. It has 1 valence electron, so it wants to get rid of it. It meets up with fluorine, which has 7 valence electrons. See, sodium wants to get rid of its extra valence electron. Fluorine's like, hey, I have 7. I just need 1 more to be stable. So sodium gives its electron to fluorine. Well, because it does that, sodium now becomes positive. Fluorine now becomes negative. So now they're kind of stuck together like magnets because opposites attract. So that's what's actually happening in an ionic bond. So there's an actual transfer of electrons. So a crystal is just a substance with a 3D repeating arrangement of particles called the crystal lattice. The coordination number of an ion is the number of ions of opposite charge that surround an ion in a crystal. So crystals aren't just gemstones. It's anything with a 3D repeating arrangement. So lots of solids are crystals, like ice is a crystal, sugar is a crystal, salt is a crystal. And then the coordination number is just the number of oppositely charged ions that surround an ion in a crystal. You do have to remember, though, that it is 3D. So like when you look at this, you may say, oh, well, it has 4 negative ions surrounding the positive. But remember, it's 3D, so there's also going to be a negative 1 behind the positive and a negative 1 in front of it. And so in this case, the coordination number would actually be 6. So an ionic bond involves the transfer of electrons between a cation and an anion. So a cation actually loses its electrons and gives them to the anion, and then those opposite charges are what hold them together. So remember, the loss of electrons is endothermic. It requires energy to take an electron away from a positive nucleus. The gaining of electrons is exothermic. So remember, it releases energy because it's favorable for an electron to be attracted to a positive nucleus. When ions come together, energy is released, so ionic compounds are stable. Because remember, that's a positive and a negative attracting, and so that's a very stable process. And so that tends to be exothermic, where energy is released. Lattice energy is the energy required to completely separate a mole of a solid ionic compound into its gaseous ions. It's like we're taking sodium chloride and we're breaking it apart into sodium ions and chloride ions. They tend to have large positive values because that means a lot of energy is required, because remember, it's very stable for opposites to be attracted. We're having to rip them apart. It's like pulling 2 magnets apart. That requires energy, indicating that ions are strongly attracted to one another in these solids. So lattice energy is based on Coulomb's law, which any kind of attractive forces is based on Coulomb's law. So we're not actually going to plug any numbers into this. The important thing to note is Q is your charge, D is your distance. And the other important thing to note is Q is on top and D is on bottom in the denominator, because that is important. So if I increase charge, or my Q values, my energy is going to increase, or my lattice energy. If I increase distance, because it's in the denominator, it's actually going to decrease my energy. Okay, so for a given arrangement of ions, the lattice energy increases as the charges increase, but as the radius decreases. Okay, so we want high charge and we want tiny atoms or ions. We want small distance between the two. So it says, arrange the following compounds in order of increasing lattice energy. So the important thing to note is it's always most important to compare charge first, then distance. Okay, so we want increasing lattice energy, so we want to go from low to high energy. So first let's look at the charges. So Na is in group 1, so it has a positive 1 charge. F's group 17, so it has a negative 1 charge. Cs is group 1, so it has a positive 1 charge. I is group 17, so it has a negative 1 charge. Calcium is group 2, so it has a positive 2 charge. Oxygen is group 16, so it has a negative 2 charge. Ooh, that was a lot. I'm going to quit saying the groups and just say the charge. Hopefully you've written down what groups have what charges. So I can automatically tell this is going to have the highest because it has the highest charges. So I'm going to go ahead and put my CaO on the high. Okay, because like I said, the charges are more important than the radius. Now these two, because they have the same charges, a positive and negative 1, I then have to compare the radius. So remember, the higher the radius, the lower the energy. Or the lower the radius, the higher the energy. Okay, so if I look, Na and F are in energy levels 2 and 3. Well, 3 and 2 if I'm putting them in order. Cs and I are in energy levels 6 and 5. Okay, so in other words, here we have a larger radius and here we have a smaller radius. So remember, the large one, the farther the distance, the lower the energy. So CSI would be first, and then this one will be second because they're closer together. So it's harder to get them apart because that's shorter distance. Okay, so remember, take care of charge first, then if you have some with the same charges, then focus on the distance or the radius of the ions themselves. All right, and so that's how you do lattice energy problems. It's just completely based on charge and radius or distance. All right, so maybe you try this one. It says, which substance would you expect to have the greatest lattice energy? So I'll let you pause it, try it, and I'll assume you've done that. So let's start by looking at charges, because if we can base it off charges, we don't even have to look at radius. So Mg has a positive 2 charge, F has negative 1, Ca has positive 2, F has negative 1. This is where it gets slightly tricky. Zr is a transition metal, so we don't know the charge. So we have to look at what it's bonded to. So O has a negative 2 charge, but since there's 2 of them, to cancel out a negative 4, I need a positive 4. Okay, so see, it has a negative 2 charge, but there's 2 of them, so that's really negative 4. So to cancel that out, I need a positive 4 charge. So since this has the higher charge, like both of these are just positive 2 and negative 1, this is positive 4 and negative 2. That means ZrO2 would have the highest lattice energy. Okay, so this one's tricky because you have to figure out the charge for zirconium. Transition metals, you have to do that frequently unless the problem just tells you. All right, so let's knock out this section assessment. How can you describe the electrical charge of an ionic compound? Well, remember, because we balance or cross charges, the overall compound is neutral. What properties characterize ionic compounds? Okay, well, we had a whole list, so let's just say 3 of them. Okay, they tend to be crystalline solids. They have high melting points. And they're made of metals and nonmetals. Again, there's more than that, but we'll just list 3 for our section assessment. All right, number 3, it says write the correct chemical formula for the compounds formed by each pair of ions. So again, notice all the positives are first, but if they gave you one where it was backwards and they put the negative first, you would have to fix it. Okay, so we have K positive, S negative 2, that doesn't cancel, so I cross my 2 down. Here we have Ca positive 2, O negative 2. Remember, a positive and negative 2 cancel, so I don't cross anything. It's just CaO. Here I have Na positive, O negative 2, so I would cross my 2 down. And here I have Al positive 3, N negative 3. Those already cancel, so I don't cross anything. So my answer is just ALN. Remember, the charges are not required. However, I don't mind if you leave them so that you can figure out what the subscripts are. But you're more than welcome to erase them. I always have some students who erase them, and eventually you'll get good enough to where you can just do it in your head and not write them at all. Alright, so it says write the formulas for each compound. So we have barium. Barium has a positive 2 charge, and we have chloride. Cl has a negative 1 charge. Remember, I'm pulling that from the periodic table, so I cross my 2 down. Next, we have magnesium oxide. Magnesium is Mg. It has a positive 2 charge. Oxide is O. It has a negative 2 charge. Remember, they changed the ending of the anion to I. That's why all of these end in I. Positive 2 and negative 2 cancel, so I don't cross anything. Next is lithium oxide. So lithium's Li with a positive 1. Oxide is O with a negative 2, so I cross my 2 down. And then the last one is calcium fluoride. Calcium Ca positive 2. Fluoride is F negative 1, so I cross my 2 down. Okay, so remember, we just cross to balance the charges. If they already cancel, we don't need to cross. So number 5, which pairs of elements are likely to form ionic compounds? Well, remember, for an ionic compound, you need a positive and a negative. So all we need to do is look at the charges. Or you can look at it as a metal or non-metal. Either one works. All right, so Cl has a negative charge. Br has a negative charge. So those would not bond ionically. Li has a positive charge. Cl has a negative charge. So those would form an ionic bond. K has a positive charge. Helium has a neutral charge, so it would not form an ionic bond. And then last, I has a negative charge, Na has a positive charge, so it would bond. However, let me point this one out. If I asked you to write the formula, though, you have to list the positive one first. So you would do NaI, like that. You have to switch it. The positive one is always first. All right, so that is how you cross charges. Make sure you get really good at it and you're really fast at it. Make sure you know those charges. Don't have to sit there and try to figure out what they are. The faster you get at this, the easier a lot of stuff from Unit 4 is going to be.